Assalamu alaikum students. We are studying a course Organic Polymer and today our topic is Ionic Polymerization. Students, already we have studied that depending upon the nature of reactive intermediates involved during the polymerization, chain growth polymerization having two types. The first type we have already discussed. The type name is free radical polymerization. The second is ionic polymerization, which we will discuss in today's topic. In this type of polymerization, alkenes can be polymerized under the influence of both cationic and anionic initiators. Depending upon the type of ionic species involved in polymerization, ionic polymerizations have further two types. One is the cationic polymerization, another is anionic polymerization. Students, in this type of polymerization, the steps involved, like earlier one, the first step is initiation, the second step is propagation, and the third one is termination. So the cationic polymerization, we also proceed this polymerization, we need an electrophile. This polymerization is called cationic polymerization because it involves a chain process that is propagated by carbocation intermediate. This is important thing. Here a carbocation intermediate will be generated. In cationic polymerization, which are initiated by electrophile agents, which electrophiles we can use, like such as the halohydric acid, for example HCl, HBr, etc. And other agents include the sulfuric acid, HClO4, etc., Lewis acid, which are electron acceptor, and compounds capable of generating carbonium ions can also initiate polymerization. So ionic polymerization, like free radical polymerization, we need an initiator, and the initiator must be electrophilic ability and they have ability to attack as a electrophile. The example of the Lewis acids are aluminium chloride, strontic chloride, BF3, TiCl4, AgClO4, etc. We can use any reagent for the attack of electrophile. So Lewis acid initiators required a co-initiator such as water or an organic halogen compounds. This is important, students. If we use a Lewis acid as an initiator, we also required a co-initiator with Lewis acid. So that co-initiator may be a water or any organic halogen compounds. So initiation by Lewis acid proceeds faster in the presence of either a proton donor, mean protogen, such as water, alcohol, or organic acids, or a cation donor, catinogen, such as tertiary butyl chloride or triphenyl methyl fluoride. So these are agents we can use for our initiation purposes, either proton donor or cation donor. Proton donor, protogen. Cation donor, catinogen. So the protogen or catinogen is referred to as the initiators. These two words, proton donor or cation donor or protogen or catinogen, is referred to as initiator, while the Lewis acid is the co-initiator, since the protogen or catinogen ultimately supplies the proton or cation which adds to a monomer that initiate polymerization. So, how we can generate a initiator? This is a Lewis acid and a co-initiator as a water. When we treat these two units, BF3 and water, it will form a moiety. This moiety is water and OH and BF3 also attached with it. So this compound we will use as a initiator. This is a Lewis acid along with water, initiator along with co-initiator. So the example of this cationic polymerization is polymerization of styrene via cationic polymerization. We will see the detailed mechanism here. The first one is chain initiation. As we already know that 3 stages are also involved in this mechanism: the chain initiation, chain propagation and chain termination. In chain initiation, this is a initiator with co-initiator. The initiator is Lewis acid along with water. And this is a monomer. Monomer is styrene monomer. When this pi bond is attacked on this positive hydrogen and one carbon of it grab this hydrogen, and how they changed, you can see clearly. This CH2 pick the hydrogen and it will convert it into CH3. And when this pi bond move towards this carbon, a partial positive charge present on this carbon, you can see here. And this remaining species, when hydrogen leave from it, this remaining species having a negative charge on it here and this positive charge on this carbon. So, in chain propagation, this chain, when this carbocation formation is take place, as we have already seen that in this type of polymerization a carbocation is formed. Now a new monomer styrene, when this pi bond attack on this carbocation center, how it will change? This CH3 and CHPH, and this CH will make a bond with CH2 and this CHPH, the positive charge came on this carbon. So look this mechanism, CH3, CHPH, and it will attach to CH2 and the positive carbocation carbon, it will appear on terminal side and BF3OH negative will remain around this positive carbon. A new monomer styrene will come and the chain and the process repeat. This process continue and the high density polymer chain will grow continually. And now the third step and the last step is chain termination. It will proceed in two ways, either proton release via proton release and second is combination with any part of initiator. So students, this is our chain. If we release or remove this small molecule from it, this Lewis part BF3 and this OH negative and this hydrogen positive carbocation, this will make a bond and chain will be terminated after releasing this small molecule. This BF3 will release and it will convert it to a chain which is ended and the product is formed. This was overall about the mechanism of Cationic polymerization, it is the first type of ionic polymerization, and the second type of subtype of this ionic polymerization is anionic polymerization. It will cover in next lectures. Hope you will understand about today's topic and the clear indication about this whole mechanism. I hope you enjoyed this lecture. Kindly share your feedback. Thank you.